Hello. This lesson we're going to talk about changing the period of sine and cosine functions. Up until this point, we've changed other aspects of these functions: vertical shifts, horizontal shifts, amplitude. But this time we're going to change the period. In the EQ, please note that there's two parts, and I would like you to answer both parts. This is really a key idea of what we are going to do today. All right, so let's review our two functions. So on the top, we have a sine graph and a sine equation. So this is our equation here. And we can see this is beautiful, smooth shape, lovely, continuous. And even though we stop here, it's going to really keep going, and it's going to keep going. And even over here, it's just going to keep going up and back, up, back. All right. So one period, right? One period is the length that it takes for this graph to complete one full cycle. And our cycle starts at 0, has one nice hill, goes back to 0, and one valley, and back to 0. So it begins and ends at 0, with 1 0 in between. So it has 3 x-intercepts in one cycle. Cosine is different. It starts up at a nice hill, and it slides down and pops back up. And that it's in its one cycle at 2 pi. So they're both at 2 pi, the length of a cycle, but their cycle is different. Cosine has 2 x-intercept. Its y-intercept is actually at 0, 1. Instead of for sine, it's at 0, 0. They both have an amplitude of 1. So we talk about a midline, a line that divides the graph, right, in half. So half the points are above and half the points are below that line. The distance from that line to the highest point and the lowest point is 1. And that's the amplitude. Remember, amplitude is always positive, even if it's reflected over the x and there's a negative in front of your function, still a positive amplitude because it's distance. So we've changed a few things. We talked about changing the amplitude, stretching it. We've talked, and when we stretch it higher and lower. But these anchor points in the center where the intercepts are, they stay the same. We talked about horizontal shift, moving all the points to the left or to the right. We've talked about a vertical shift, moving all the points up or all the points down of the equation. Now, what if we change the period? What if the period, instead of 2 pi, what if we did one whole cycle at 4 pi? What does that do to the graph? What if we had a period of pi over 2? That one full cycle fits in pi over 2. What does that do to the graph? So that's what we're doing today. Now, before we actually do graphing, we have to talk about the equation. And so this is the equations up until this point that we've used, A being the amplitude, H being the horizontal shift, and K being the vertical shift. But we did not talk about changes in the period yet. So here is true final equation. Here's for sine, and you can see this B. This B will change the period. Now, it can be factored outside of your variable, but it still be after your function, the word sine or cosine, or it can be factored. Now, if it's in factored form, we have to, if it's not factored, if it's multiplied out in here, we actually have to factor it out. One is because if we don't, you're going to think that the whatever number that is going to be the horizontal shift. But there's actually two things here. There's the horizontal shift and the B there. So this is why we have to factor out B. And we'll practice that. No worries. And today we're just going to focus on the period shifts. So we're not going to do period and horizontal shifts. They are more complicated, and we're going to do that and wait for the next lesson. So we can see the key for the variables here. A is our amplitude, H is our horizontal shift, also known as a phase shift. K is our vertical shift, moving up and down. And for sine and cosine, our period, to find the period, you're going to do 2 pi over b. Yes, this is only for sine and cosine. Cosecant is secant. So this is the formula we're going to use. Okay, so we have to find the b and then use this. This is 2 pi, which represents the cycle for a parent function. Okay. So let's practice just with the equation of finding the period. So the first thing we have to do is find b. So where is b? B is going to be in front of the x. And you don't need to factor it necessarily for this one, because it's straight just in front. But you could if you wanted to, because it'll just be this. 8 times x, so really it's the same thing. So my b is 8. Then to find the period, it's 2 pi over 8. And yes, you have to simplify it. So that's going to be pi over 4. So what does that mean? Really think about that. So if I have a regular parent graph assigned, looks like that, but it's saying, okay, it's now pi over 4. One full cycle has to fit in pi over 4. So this is going to be pi. This is pi over 2. So pi over 4 is here. So it's saying that full shape, one up, one down, one hill, one valley, has to fit there. So watch, it's going to look like this. Boop. So it's really compressed, really squished in there. All right, so let's look at this one. Okay, so what's B? B, you can see, let's take that out, it's 1/4. So B equals 1/4. So the period is 2 pi over 1/4. Okay, so I'm going to get rid of the denominator and multiply them by 4. That's going to give me 8 pi for a period. So let's look at that again. So if 2 pi is about here and our sine's here, well, 8 pi is probably longer. So one full cycle, just one, has to fit through there. Well, halfway would be 4 pi. So that means it has to be like this. So what happens to it? It's right, it's really stretched this time. So it's much slower because you have 8 pi to do something and that you usually only would do it in 2 pi, so much longer. So look at the b's and compare between 1 and 2. Right, that's a whole number bigger than 1, and this is a fraction, less than 1. All right, so let's look over here. Okay, so my b is here, but I'm going to practice out factoring because it's good practice for us. All right, so 3 times what will get me 4? So I want that 4 by itself. So if I had 3 in the denominator, those 3's would undo each other and you would have 4 left. So you can see my H is not really 4, my horizontal shift, it's actually 4/3. This is why we need to factor out that 3. It changes. All right, so my B equals 3. So the period is 2 pi over 3. I can't simplify that, so that's the answer. Now for this, you can see that we're going to have to do some fraction work. We can see that when I did these quick sample graphs that I cut, 2 pi in half and then halved it again and then halved it again. And over here for the 8 pi, I halved it again to be able to find where our points, our anchor points would be. All right, let's practice graphing. Okay, so for this one, I'm going to ask you to draw a parent graph so you can compare between the two of what's really happening. But I'm not going to ask that for all the graphs. Okay, so if we're looking at here, what's my b? My b is 2. And before we graph, we always need to find the period, because they'll tell you, again, the length of one cycle. And that can be very small or very big. All right, so that's going to be 2 pi over 2. Simplifies out, so I just have pi. All right, the amplitude's 1. These are 0. Okay, I'm going to graph the parent graph. Okay, cosine, so it's up. 0, 1. I don't know if you've ever noticed from here to here, there are 8 lines. 1, 2, 3, 4, 5, 6, 7, 8. Something that 4 can divide into evenly, because again, it has to do with quarters, quadrants from the unit circle. All right, so now let's talk about the period, how that changes. So this is our one normal cycle at 2 pi. But it's saying, hey, it's going to be at pi. So from here, you don't always have to put these vertical lines, but I'm putting them just so you can see, right? Because here's pi. In that one period, right, you have to go up, down, up, all in that area. Okay. So you have to have, we're going to start here, right? And then at that period, it has to end. So instead of ending here at 2 pi, you're ending here, but still has to be, remember for cosine, you start at 1, you finish at 1 cycle. Halfway between pi and 0 is pi over 2, and that's going to be the lowest point. And the points in between will be the x-intercepts. Right? There you go. So what happened? We compressed it. It's a smaller cycle, smaller period, so it has to be compressed and squished in there. We're going to do another cycle. So again, another pi here to here. So it's going to finish there. Halfway is going to be on the bottom. X-intercepts. Smooth graph. You'll have 2 cycles. I'm going to do more. Again, this is just to show you where it's going to stop and start a new cycle. I generally don't put those in. To show you there. So the nice sinusoidal wave, nice shape, smooth and curvy, label that, that's my graph. So you can see that the period is smaller. So you have more cycles. So in 2 pi, now I have 2 cycles instead of 1, twice as many. All right, let's go to our next graph. All right, our next equation is a sine graph, or sine function. All right, our b is 1/3. So our period is 2 pi over 1/3. And multiply by 3, that's 6 pi. Okay, 6 pi. It's 1, 0, -2. Now, for this one, I'm not going to draw a parent graph because I've changed the period rather drastically. And instead of trying to, draw 6 pi way out here, I'm just going to change the scale. And this is why writing our axes and scaling is so important. So here, if we count out 8, I did that earlier. 1, 2, 3, 4, 5, 6, 7, 8. Usually it's 2 pi, but this time I'm going to say 6 pi. So it's going to still have our same shape. It's just our scale will be different. So what's half of that? So we're going to take 4, that's here, and that's 3 pi. So what's half of that? Well, it's the average between 3 and 0 divided by 2, so that's 3 pi over 2. Now, how do we find this one? Well, that's the average, right, between 3 pi and 6 pi. Well, you add them together. 3 plus 6 is 9 pi, and divide by 2. By how many there are. Okay. So then we're going to go backwards and do it this way. 1, 2, 3, 4, 5, 6, 7, 8. So not the last ones. Don't put it there. That will mess you up. So halfway it's 3 pi. Negative 9 pi over 2. Okay. So if I had to sketch a paragraph for this, but now we're in a different scale, it'd be here, here, here. Here's your points, right? So it still has the same shape. It's still what we are used to. Then now we're going to, but we've changed the scale. Because 2 pi would actually, be over here somewhere. All right, so then we're shifting all the points down 2. So 1, 2. Sorry. All right, so my midline is going to be here. Okay, so we are here. We're going to go up 1, okay, and then back to my midline. Down 1, and back to my midline. Okay, going backwards down to the midline. Up to the midline. And there we are. Okay. G of x. All right, let's try this one. Okay, so b equals half. So this is going to be, period is 2 pi over half. Multiplied by 2, that's going to be 4 pi. Okay, my amplitude is 3, but I'm going to reflect it. This is going to be no horizontal shift and up 1. Okay, so I think for this one, what I'm going to do, I think I'm going to graph this first. So you guys could kind of see what that looks like. So I'm not going to do a paragraph, but we're going to do your x and y. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So I'm going to go out to 8 here. It's going to be 4 pi. Half of it here, 2 pi. Half of this is half of 2 pi is 1 pi. Half of here is 3 pi. To double check, 2 pi plus 4 pi is 3 pi, right? The average. Sorry, 2 pi plus 4 pi is 6 pi divided by 2 is 3 pi. My bad. That sounded totally wrong. Here we are. Okay. So I'm thinking, I don't know if I want to do this graph or maybe we want to do this one first. You know what? Let's do this one. Might be easier for you guys to do this first. Okay. Just to see how that changes in the stretching. Okay. So because it's cosine, you would usually start at here at 1, but we're going to go up to 3, right? And we're going to go here, to here, to there, to there. Okay. Okay, I'm trying to do dots. Do you know it's not very good with, okay, there. Dash is not good. Dots good with tablet. Okay. So you can see that the amplitude, it really stretched it, right? It is now by 3. Okay. So now the negative, it's going to flip all those points upside down, and then we have to move them all up 1. So instead of here, we're going to go here, and then we're going to go up 1. Okay, you know what I'm going to do? I was going to do that midline. It'll help us. So then this will be here, and this will be here, right? We're moving up those points. X-intercept, they do not reflect. When you do this, they don't reflect. They stay on that midline. So here, right? Reflect it down, then up 1. So down here, we're going to reflect it here, and then move it up 1. Here, we're going to reflect it here and move it up 1. Same thing with this one. We're going to reflect it and then move it up 1. Here, we're going to reflect it, move down 1. Or reflect it here and then up 1. Okay. So this goes up. This is h of x. Oh, that was beautiful. All right, so let's double check. All right, so if I'm looking at this, I can tell that, yes, it's reflected because it's a cosine. It should have started up here in the positive, but it's not. It's in the negative. It's 3. Okay. So from the top and bottom, you see 1, 2, 3, 4, 5, 6. So half of that is 3. So definitely that's an amplitude of 3. Our pi is 4 pi over, sorry, our period is 4 pi. And we can see that from here to here. And we can see that everything moved up 1. Usually it would have been at -3, but it's not. It's at -2. Here would have been at 3, but now it's at 4. So we added 1 to everything. So just checking our graph in 2 full cycles. All right, writing an equation. Okay. So let's talk about writing an equation. We're going to do a sign, and we're going to do, period. So this one's different. So here we have to find B. So we're looking for B. Okay, that's what we're looking for. And we have the period of 2 pi, period equals B. All right, so that is what that's what we're going to use to find our B in our equation. So our period is 6 pi equals 2 pi over B. So we're going to cross multiply. So that's going to be B times 6 pi over 2 pi, and then dividing. B equals 2 pi divided by 6 pi equals 1/3. So that's our B. Okay, so my equation is f of x equals, all right, sine, amplitude of 3. My B is 1/3, so it's x over 3. Reflected over the x-axis, so that's going to be negative in front. You can put a parentheses if you want to or not. It's up to you. Okay, let's find B. Period. So period is 8 pi equals 2 pi over B. Oh, so I'm going to cross multiply that. So that's pi times B equals 16 pi. Okay, so my pi's are going to cancel out, so b equals 16. Okay, so it is some function I can call f of x. My amplitude is 2/5 sine of bx. And I have a vertical shift, so I'm going to put parentheses around that and up. So that's plus 9. Right. There's your equations. So it doesn't look like 91. My bad. All right. Here is your practice on your own to graph. Don't forget to label the x and y axes and answer the EQ. Thanks for watching. Bye.